It's called. Is it gonna work?
Here, I'll just do that.
Thank you. Give me a reaction. So it's okay there.
Sorry, it's quiet. I thought I edited it to make it all sound, but apparently I'm not good at iMovie, so sorry about that. But is that you, Connor? Yeah, that's me here.
You can talk us through this thing.
Yeah, so this is elephant toothpaste. So this is one of the experiments that we'll be doing. We didn't decide. I just filmed it because it was kind of messy, so I didn't want to have to leave during the presentation and clean up everything.
Okay.
But basically, you mix just soap, water, just soap, hydrogen peroxide, and yeast and water together, and it creates foam. And then I just decided to just do it in slow-mo so you guys could see it again. But with this, it's a decomposition reaction, so it's really similar to vinegar and the vinegar and baking soda reaction. This is a reaction that happens when hydrogen peroxide decomposes rapidly to create water and oxygen, and then yeast acts as a catalyst. And then once the water, oxygen, and just soap go together, it creates foam. This is an example of an exothermic reaction because it produces heat. It's not enough to burn, thankfully. The ones that we use, the hydrogen peroxide, it's like the one that you put on your skin for burns and that kind of thing, so it won't harm any students and that kind of thing. But I know with the original experiment, they used really high hydrogen peroxide, and that's what makes it a really big reaction. I was thinking, I didn't have any pop bottles at my house, but for the actual experiment on the day, I'm thinking of using an actual pop bottle because the hole's smaller and it will create more of a foam effect, I think. But we only are gonna do this one a couple times an hour, not just individually, just because it's kind of hard to clean up, but it'll be more of a demonstration. I was thinking of having the kids help me make it, so someone will pour in the soap and someone will pour in the yeast and that kind of thing, but when I'll be the one putting the two things together so they don't get harmed. But this demonstrates quick, fast reactions. We wanted to show different reactions, slower and longer ones. We were gonna originally also do crystals, but that is a very slow reaction and that wouldn't work during our day. So we were thinking of giving little handouts so they could have the recipe to make it at home as well. But yeah.
All right. So we just saw a big chemical reaction. So now we're going to move on to a slightly smaller one. And this is one that everyone's going to get to do. Now, this might surprise you, but slime is indeed a chemical reaction. So we are going to be making two different kinds of slime. One is a mixture of cornstarch and water, and the other is a mixture of cornstarch and soap. Both of these are a mixture of a liquid and a solid. And we decided to choose two different types of slime in order to show that during chemistry, changing even one ingredient in a reaction can vastly change the outcome that you get. So the water and cornstarch will end up creating what is called a non-Newtonian fluid. Does anyone know what a non-Newtonian fluid is?
Not liquid, not solid.
Yes, pretty much. It is essentially a substance that changes its density based on how much pressure and force is applied to it. So if you hit it really hard, it's more like a solid. If you move your hand slowly through it, it's more like a liquid. A good example of this is actually quicksand. Quicksand is considered a non-Newtonian fluid. Meanwhile, the soap and cornstarch should essentially create a putty of sorts. These are reactions that are not necessarily big or flashy, but since not all chemical reactions need to be big and flashy. Heck, some solutions, mixture of solid and a liquid, cereal and milk. Technically a solution, technically still chemistry.
All right, now it's time for slime time. So how we're gonna do this, we're gonna have you work in your table groups. So for the front 4 table groups, we're gonna have you mixing cornstarch and soap And for the back 4 tables, we're gonna have you mixing cornstarch and water. So what I want is one volunteer from your group to come up, and we'll give you the materials you're going to need. For the water, we have a water bottle, or you can go fill it up in the hallway quick, put some in there. But we just want you to experiment with different amounts of cornstarch, different amounts of water, different amounts of soap, and see what sort of different consistencies you can get when you're making your slime. So you can work as a group, take it out, feel it a little bit, just make sure to clean off your tables afterwards. And we have wipes as well.
If you guys want more cornstarch, you can come up and we can give you more cornstarch.
And there are extra bowls for the water people, so you can get a bowl of water if you want to like slowly add to see how it turns out.
So yeah, so we'll get each one of the tables to have one volunteer come up and grab your materials you're gonna need to make your slime.
So people, there's only like 2 soaps.
You'll have to share. And you guys will have to share the yes. Yeah, you can pour in as much or as little as you want.
Here, do you
Stand
want
up.
to give them a bowl for water?
Just kidding. 360. I think you're gonna need it.
Oh, so there's only 2 bowls.
Deal with it.
You can take your bowl and then you'll just have to kind of share.
You'll share with that house. No. So get to take a little bit of soap.
If the teacher wants to try one, feel free to. We have an extra bowl.
Jason, we have an extra bowl if you'd like to try one as well.
It's okay if somebody else really wants to go, we'll,
Otherwise, we can just here. More?
Yeah, sorry. No, it's okay. Oh, here, I got
Teachers don't want to do it.
Oh, did I get it on you? You're gonna smell really nice. Uh-oh, making a mess. More? Now that I'm